Let me point out that there are three flavors of probability. One that's classically derived, a second that is calculated from empirical evidence, and a third which is the opinion of an expert. All three flavors are relevant in their particular settings. When I flip a fair coin, I can expect that it lands heads half the time. We say the classical probability for that event is 1 by 2. Now suppose I toss this coin 100 times and obtain 55 heads. You know that can happen. Then the empirical probability that this coin lands heads is 0.55. In most business settings, we have to make decisions based on such empirical evidence. Historicals for stock prices, point of sale transactions, and so on. The probabilities we derive are conventionally called likelihood. Finally, there are occasions when empirical data alone may not suffice to come up with a probability number. For example, a publicly listed firm's stock price movements may not fully determine in which direction the stock is going to swing the next day. Experts who have a good understanding of the company's industry sector can make a better call on that. They usually couch their forecasts using the language of probability. You may have heard on television 90% chance that it's going to shoot up and so on. Let's get started. As usual, we won't touch the original data. Instead, we'll make a copy of it into an analysis tab. And for our convenience, I've already done that. Now the original set has missing data. One easy way to spot them is to use filters, and in our case, select those rows with question marks. So I'm going to show how we do this here. Filters, and if I were to look at working class, I already have a question mark over here. And if I were to just select those with question marks, I get a lot of them. Now, advanced data modelers will try to replace those values with some intelligent choices. In our case, we'll keep it simple. We'll move them all out to a discards tab. We are left with a little over 30,000 rows in the analysis tab, of course. On a funny note, there was one husband who was classified as female and one wife who was classified as male.
How did you figure that out?
While constructing a pivot table, usually we need a mix of systematic thinking and a dollop of good luck to be able to spot such errors. I hope you've practiced building pivot tables. We will be using them to derive likelihoods.
Otherwise, you could visit our segment on the same topic.
We're going to make use of this cleaned up data set in the analysis tab as supporting evidence for our questions. Here are some starters. If we select a row at random from our data set, what's the likelihood that the person concerned makes over 50K? This question will motivate our working definition of probability. Next, if we select a row at random from our data set, what's the probability that it's a female making over 50K? We'll build a pivot table and formulate the answer to this question as a joint probability. Third, if we select a row at random from our data set, what's the probability that the person concerned is female? For this, we'll use the same pivot table and point out marginal probabilities. Now let's move into the realm of an MBA. Given that a person is a managerial executive, what's the probability that he or she makes over 50K? I'm going to flip this a little. Given that a person makes over 50K, what's the probability that he or she is a managerial executive?
Aren't you just stating the same question?
Not really. Any novice will find it hard to make out the difference between these two versions. The answers are quite different though, and they are based on what are called conditional probabilities. Whenever there are multiple categories for a variable, there's scope for us to detect some patterns. For example, if we focus on people who make under 50K, then is the gender divide similar across the races? This underlies the statistical notion of independence. When it comes to sensitive topics such as race or gender, it's natural for many of us to make reactive statements. Let me ask a question. In our data set, is it more likely that a white female makes over 50K compared to females from all other races?
I'll bet it's a yes.
Didn't you just hear what I said? It's best we settle this with a rigorous analysis. An expert analyst rarely speaks from the gut. In his book Black Swan, Nassim Nicholas Taleb writes about fallacies or mistakes involving probability. There's a huge difference between proclaiming that most terrorists are Muslims versus most Muslims are terrorists. The second is a knee jerk reflex and can adversely color our impressions about people. This is why I would say a sound understanding of quant concepts is just as essential as an ability to appreciate fine art.
I'm a fine combo of these two.
And you're very humble too. In this segment, we explored a data set that we downloaded from the UC Irvine Machine Learning Repository. We drew up a list of questions for us to answer next based on a pruned version of the training data set. That's what is in the Analysis tab. We hope you've developed enough intuition to come up with a list of questions of your own. After all, you'll need that skill to analyze any dataset that might crop up in your line of work.
Where are the answers?
For that, you have to keep watching.